So we are going to be working on proofs with angles, and we're going to notice today that the angle proofs have similarities to the segment proofs. So one of the things that we did in the segment proofs was if you had like segment AB is congruent to segment CD, one of the things we could do is take the bars off, or we could put the bars and squiggly back on, and that was called definition of congruent segments. So we have a step that's just like that for angles. So today, sometimes in our proofs, we're going to be given that two angles are congruent, and then what you can do is take the squiggly off and add these M's. Do you guys know what those M's are for? Measure, right? So when you take the squiggly off and add the M's, or take the M's off and add the squiggly, that is called definition of congruent angles. Now, the reason we do this, both with angles and with segments, is you can't substitute in to like measures into a segment, but you can into, once you take the bars and squiggly off, these mean measure. Same thing here, you can't substitute a measure in when the angles are congruent, but once you put those little M's in front, you can substitute in for that, okay? Then if I look here, this was what I was talking about where we talked about if you had a segment with 3 parts or 3 points, that you could break that segment into parts, and you could say AB plus BC equals AC, and that was by segment addition postulate. Okay? Now, when we have angles, and when an angle has 2 angles that are part of it, so kind of inside the one angle you have 2 different ones, you can break that angle into parts just like we took and split our segment into parts. So what we can do is say that this plus this equals the whole thing. And yesterday I talked about the fact that what's a little bit of a pain with this is that when you go to name the angles, you have to use 3 letters. So like they did the first, they took the big angle, so they called it measure of angles CAB, and then they said that that was equal to measure of angles CAD, which is this one. Whoops. This is not liking me today. What did I do? Okay, so then it would be plus measure of angle CAD plus the measure of angle DAB here, okay? So they took that angle and they broke it up into 3 parts, and we will be doing that again today quite a bit. Now on your cheat sheet, I had a thing that said what to do if you were stuck on a segment proof. This is what you're going to do when you get stuck on an angle proof. And I'm guessing, can I just look at yours real quick to make sure that is on here? It is. This is on the top of the second full page, this right here. So like I said, you wouldn't have to memorize this, but what you can do today is if you have angles that are congruent, like angle ABC is congruent to angle DEF, and you're stuck and you don't know what to do, you can take the squiggly off and add the little M. Okay, one that we do a lot. Then the other thing, if you get stuck, don't forget that if an angle has 2 parts two angles inside of it, you can take that angle and say that this plus this equals the whole thing. Once you get to that point, that's when I suggest you guys look at your proof statement and see if that gives any tips as to what you can do. But what you're gonna have to do there is use substitution as your next step to try to get to that proof statement, okay? So we're gonna try a couple today. We're gonna do these 4 pages today, and then we finish it up afterwards, okay? Well, we do this one and 3 more. So this proof on your packet, I think is earlier in the packet. I think we skipped it yesterday. Everybody find it? I kind of rearranged the packet. Okay, so let's go ahead and try this one. Sometimes I take proofs out of any spot I can find them. And this particular, wherever I got this one from, instead of numbering both sides, they do letters for the steps. And that's fine if you would rather do that. That's what they did. One thing that's a little confusing about this one, notice A is here, but the reason for A is down below. So that gets a little bit confusing. Their A's and their B's don't match up. Okay, so let's look. First thing we're gonna do is we're gonna write down our given. Okay, and then A is given. No one should ever get that wrong. Okay, now, do you guys see what they did from step A to step B? Very good. They took the squiggly off and added the M's. So that is definition of congruent angles. And you can always make an angle with an apostrophe S to represent angles if you want to. Like I said, for some reason, their A, B, C, and D on the right doesn't quite match up with the left. Now, when we had segments, I was always telling you guys, like if you saw this, where 2 things were added together to give you 1, I said always look at the segments and see if they broke it into parts. If I look here, they have 1 angle equal to 2 added together, 1 angle equal to 2 added together. That's when we're gonna look at this diagram and see if they split an angle into parts. And you can do that anytime you have an angle that has 2 angles as a part of it. So what they did in this first one is they said measure of angle QPS equals the measure of angle QPR plus the measure of angle RPS. So that is what they did there. Now, what do you guys think that is? When you take an angle and break it into parts. Angle addition postulate. Very good. And I just make an angle addition and then post, if you want to do it that way. Okay? And that was the reason for the second part of C2. What they did in that one is they took this angle and they broke it up into angle TPS plus angle RPS right here. So they split both of those bigger angles into parts. Now if you look, they want us to do substitution. So what I need to do there is look at what can I substitute? And do you guys see up here where this is angle QPS as well as this is angle QPS? And angle QPS is this whole thing. So what I can do then is I can take this and add it in there, okay? Substitute it in there. Now they have that angle TPR is equal to this blue box. So TPR is up here. I can pick that out and put this blue box in there. And that's what they did. So this one you're gonna have to kind of write small because you're gonna be setting your pink box equal to the blue box, okay? So it's gonna be the measure of angle QPR plus the measure of angle RPS equals the measure of angle TPS plus the measure of angle RPS, okay? And that is substitution property. Now, what I suggest you guys always do is go back to what it is you're trying to prove. And if I look at this proof statement, eventually what I want is I want to get that angle QPR is congruent to angle TPS. Can I do something with these two because they're the same? I can subtract them, right? So what I could say then is the measure of angle QPR equals the measure of angle TPS, and that would be subtraction, and make sure you go SUBTR and then prop. Now the last thing that I have to do there is I just have to take off the squiggly, or I'm sorry, put back on the squiggly and get rid of these M's so that it looks like this. So I'm going to say angle QPR is congruent to angle TPS, and that is by definition of congruent angles. Okay, so that's a super common proof that you could see in this chapter. Questions on that? Okay, now we're going to go through a couple things really quick and then do two more proofs. So when you learn new things, a lot of times you again get reminded that these work for reflexive property, symmetric property, and transitive property. I never make you guys write the of congruence, so you don't have to worry about that. You would just say reflexive property. But what this is saying is with congruent angles, you can use reflexive property where one angle is congruent to itself, okay? Then we have symmetric property, and that's where you take the two angles that are congruent and you flip them around, okay? Switch them around. That is symmetric property. And then with transitive property, remember that's the one where the ending of this and the beginning of that are the same, and you cross those out and say that the outside two are congruent, okay? So that we've learned before, it's just showing us that that works for congruent angles also. Now, these two theorems, if I just read them to you, you're gonna think like, what does that even mean? But it really isn't hard to understand once you put numbers in. It says if you have angles supplementary to the same angle or to congruent angles, they are congruent. So here's what it's saying. It would tell you in a proof that angle 1 is supplementary with angle 2, and that angle 3 is supplementary with angle 2. And what this theorem is saying is that would mean that 1 and 3 would be congruent. So I'll just give you some numbers. If this was 60 and I told you guys that 1 and 2 were supplementary, doesn't that mean this one would have to be 120, right? And then if I told you these two are supplementary, wouldn't this one also have to be 120? So what this is saying is if you have two angles supplementary to the same angle, the only way that's going to happen is if these two are equal, okay? We don't use this so much as a reason in a proof, but we do prove this theorem today. And that happens every once in a while in geometry where you'll get a theorem and then they'll ask you to prove it. So this one here we also prove, and it's very similar to the one above. It says angles complementary to the same angle or two congruent angles are congruent. So again, let's say this was 60 degrees, and let's say you were told 4 and 5 were complementary. How much would 4 be? 30. And then let's say they told you 6 and 5 were complementary. This one would be 30. So if you have two angles complementary to the same angle, the only way that's happening is if those two are equal. Okay? So what we're going to do next is we're going to prove that first theorem that I just went over on the previous page. This is what we're given, and this is what we're trying to prove. So notice for step 1, that is what we are given. Angle 1 and angle 3 are complementary, and angle 2 and angle 3 are complementary. Okay? Now, this next step is one that we only do in this proof right here, so I'm not going to have you write it in your cheat sheet, because this step right here we'll never use again. But if they tell you two angles are complementary in a proof, you can say their measures add up to 90 by the definition of complementary angles. Okay? I think I was saying supplementary, but this is the complementary one. So, like I said, anytime they tell you two things are complementary, you can say they add up to 90 by definition of complementary angles, but that isn't a step we do after this proof at all. Now, do you guys get that these two sides are equal? And does it make sense to you guys if these two sides are equal, that those two sides would be equal? So what basically you're doing there is 90 is equal to this, and there's a 90 here, so you can pick this out and put that green box in there. So that makes these two sides equal. When they do that, what do you think that would be? Yep, substitution property. Okay, now does anyone see what they did from step 3 to step 4? Subtract, right? Didn't they subtract the measure of angle 3's? There was an angle 3 on both sides, so they did subtraction property. Now, one thing, I just graded my high school tests for this part, and this is one place they lost points. Make sure when you do substitution, you do the ST on the end. When you do subtraction, the TR on the end. Okay? Now, from here to here, can you guys tell what they did? Yep, they took the M's off and added the squiggly, and that's definition of congruent angles. Okay? Now, let's go and do this next one, and then you get your assignment. Okay? So this particular one, we have 3 givens, okay? Notice they put all 3 givens in step 1. So for step 1, we just have to do given, okay? Do you guys remember on this last page that they told us that angle 1 and angle 3 are complementary, and we said their measures add up to 90, and that was definition of complementary angles? What do you think we would do, say for a reason, if angle 1 and angle 2 are supplementary and their measures add up to 180? Yeah, definition of supplementary angles. Very good. And again, this is one we don't we don't use after this proof, okay? Now, this is what we have, and do you guys see how they went from step 2 to step 3? Yeah. Do you remember how I said if these two sides are equal, these two sides are equal? And that's always going to be substitution property when that's the case. If these two are both 180, then those two have to be equal. So you can say those two are equal, and that's substitution property. Now, basically what they did there is 180 is equal to this green box, and there's a 180 there. So they picked the 180 out, and they put the green box up there. So that's really what they did. Now, when you guys are doing these proofs, you're normally what you're normally gonna look at when you get to step 4 is you're gonna look up here. And you're gonna be like, how can they go from this step to this step? Because you can't subtract two things that are different, okay? Does anyone see what they did for this? This one's kind of hard. They went back up to this in the given, and they took the squiggly off and added the M's. That's all they did. Took the squiggly off and added the M's. What is that called? Definition of congruent segments. Or no, angles, sorry. Congruent angles. Okay? So every once in a while that'll happen where you're not really sure what's going on, and if you look way back up to the given, sometimes they bring that given in after the fact. Now we have to figure out what they did from this step to this step. Does anyone see what's different there? Yeah, what did they substitute? Yep, they picked this 4 out and they put measure of angle 1 in there, okay? So that would be substitution property, okay? So the measure of angle 1s were the same, measure of angle 2 was the same, measure of angle 3 was the same, but you'd notice these are different, and they can do that by substitution. Now can you tell what they did from step 5 to 6? They subtracted the measure of angle 1. And then last step, they took the M's off and added the squiggly. What's that? Yep, definition of congruent angles. Okay? So, I think your assignment is short today, if I remember correctly. So you have 2 problems to do in the book, and then I'm going to give you guys a worksheet. Okay, I'm lying. I thought it was a different assignment than today, but on the worksheet, you guys, a lot of it is actually what we did yesterday, not today. You'll have some proofs to do, but on the worksheet, there's a lot of what we did yesterday, finding missing angles.
Keep it pushing, boy.
So do the 2 book problems on notebook paper. If you're copying it out of the book, do the given, do the proof, do the diagram, statements, reasons.
We only have to do 1 through 9?
8 and 9.
Oh, so the whole thing.
Yesterday gave me assignment.
I'll lose that. So we don't have to do 6 and 7.
That could be, let me check super quick.
Do we not have to do 6 and 7?
In the book you're saying?
So we, do we have the whole worksheet to do?
Yes, you did 8 and 9 yesterday. You're correct. So don't worry about the book part. I'm sorry. You guys did that already. You're just doing the worksheet and look at the upper right corner as to which ones you have to do on each side. Okay? So you're only doing the worksheet. Sorry about that.